Okay, here's a short video of the foldable that we did in class today. If you were absent or if you're in third period and you need to do this, this video is for you. I gave out a piece of green cardstock. If you have a piece of paper or colored piece of paper or just a plain white sheet of paper and you want to do it on that, that's fine. If you would like some of this paper, just ask me and I'll give it to you. What you're going to do is you need to fold the paper in half so that you know where this halfway mark is right there. That's the first thing we did, was fold it in half. When you have that halfway marked, you're just going to fold these ends in, okay, and you're going to make it so that it's going to open up like a book. After that, you're going to want to fold it in half this way, so this part is going to come up like that. Or you can measure and find the halfway mark here and here, and then just take a ruler and draw a line, and you'll just cut right here, okay, so that you want it to open up, okay. If you don't follow my instructions exactly to the letter, it's fine, as long as your foldable looks like a window. It should look like a 4-pane window, and it should open up at the top, and it should open up at the bottom, okay. Make sure you trace around your window panes so that you know where to put your words, okay. So at this point, I'm just going to show you what's on the foldable, and you can freeze frame it and write the words down. I will read the whole foldable for you, just in case there's any words that you couldn't read my handwriting, or if it's blurry, I'll be reading every word to you. This is perpendicular, bisector, angle, bisector. Down here, it's median and altitude. When we open it up, okay, we have a picture of a perpendicular bisector. Notice that it does not go through the vertex. Do not make this line go through the vertex. It's not in the definition that it's supposed to go through a vertex. So I had a lot of people, or I had one person in first period draw their line right there. That's not accurate. It needs to be through the midpoint. Okay, midpoint. Okay. This is a picture of an example of a perpendicular bisector. This is a picture of the theorem. If you need explanation on the theorem, this is from section 5-1, so you can go back to that video. This is the definition. It goes through the midpoint at 90-degree angle. The theorem says any point on the perpendicular bisector is equidistant to the endpoint. Its point of concurrency is the circumcenter. Definition of angle bisector: goes through the vertex, divides angle into two congruent angles. The theorem is any point on the angle bisector is equidistant to the sides of the angle. Its point of concurrency is the end center. Again, this is a picture of just an example of what one looks like, and then this is a picture of what the theorem is telling you. Okay, again, if you need any help on understanding this, the rest of the notes for that is in section 5-1. And again, this isn't full notes. This is just a foldable kind of organizing all the information. So full explanations are not going to be in this video. Alright, this is median. The definition goes through the vertex and a midpoint of the opposite side. Centroid divides the median into two sections.
Remember, you do have the opportunity to go to the cafeteria instead of attending the pep rally. If you are going to do so, you need to move when your room empties. You need to go immediately to the cafeteria. There's no starting one way and going the other.
Centroid divides the median into two sections with a ratio, 1-to-2 ratio. Point of concurrency is centroid. Let me talk about these pictures real quick. Again, this is just an example of what one looks like. This is the theorem. To make sure you draw this picture accurately, you're going to want to start with the midpoint. So just kind of eyeball where the midpoint is and then draw a line to the vertex. Same thing here. Find the midpoint, draw a line to the vertex, find a midpoint, draw a line to the vertex, find a midpoint, draw the line to the vertex. If you can't draw this, I understand that this is a difficult picture. Bring it to me in class and I'll draw it for you. Okay? Don't fret over it if you can't do it. Just let me know and I'll help you. Alright, altitude, almost done. Goes through the vertex and is perpendicular to the base. Here's the picture for it. Its point of concurrency is an orthocenter. There is no theorem for this word. Then we had our fifth special segment, which is from 3-4, which was the mid-segment. Mid-segment goes through two midpoints. The theorem is that the base is equal to 2 times the midpoint. There is no point of concurrency, which is why this is not a part of the foldable. It is our fifth special segment, but it doesn't fit in with the other 4 because there's not a point of concurrency. But I wanted it at the bottom of the page just so you didn't forget about it. Alright, and that's it.